Right now, the world is at a tipping point. Energy demand is rising, climate change is accelerating, and in Canada, where extreme weather is becoming more common, finding cleaner, more sustainable energy solutions isn't just important, it's urgent. One of the most promising breakthroughs in this transition is something that sounds futuristic, but it's already here: hydrogen fuel cells. These devices are changing about how we think about electricity and transportation, not only globally, but right here at home. Canada has become one of the world's leaders in hydrogen innovation, pushing this clean technology from concept to reality. Hydrogen fuel cells, fueling a cleaner Canada, by Jake Brady.
Hydrogen fuel cells are a clean energy technology that generate electricity using hydrogen gas. They power things like vehicles and buildings without producing harmful emissions. The only byproducts are water and heat, making them an eco-friendly alternative to worse energy forms like fossil fuels.
For now, let's look at some of the uses and impacts that hydrogen fuel cells have on our society. Hydrogen fuel cells have been implemented in many different aspects, including electric vehicles, backup power systems, and even as the primary power source for some off-grid buildings. In vehicles, a hydrogen fuel cell may be 2 or 3 times more efficient than a normal gasoline-powered vehicle, and can last for far longer than any battery-powered EV. However, both the high cost of vehicles and limited hydrogen fueling stations have limited the number of hydrogen-fueled vehicles in use today. Production of hydrogen-fueled vehicles is limited because people won't buy the vehicles if hydrogen refueling systems aren't easily accessible. Fuel cells can also be used as backup power supplies or power entire buildings, which can prove far more efficient and greener than the alternative of fossil fuels. The largest problem with hydrogen fuel cells today is the cost. They're simply too obscure to mass produce, and without that, the price remains higher than the alternatives. Environmentally, fuel cells are almost entirely emission-free. The only emissions come from the production of hydrogen gas. The hydrogen used comes from a process in which natural gas is used and does release emissions into our atmosphere. There are ways to generate hydrogen without emissions called green hydrogen, but this process is very expensive. Aside from this, when used in vehicles to generate electricity, hydrogen fuel cells do not release any emissions into the atmosphere, meaning they are a far better alternative than fossil fuels. In Canada, fuel cells are especially relevant in provinces like BC and Quebec, where hydroelectricity is abundant and can be used to produce green hydrogen. Canadian companies such as Ballard Power have become global leaders in hydrogen fuel cell technology, particularly for buses, trains, and backup power systems. Beyond transportation, they are being tested in more remote communities and mining operations to reduce reliance on diesel. These versatile applications show hydrogen fuel cells can combine to Canada's energy transition while leveraging our own natural advantages. Now we'll look into some of the chemistry behind the hydrogen fuel cell. Hydrogen fuel cells operate based on redox reactions, which are reduction oxidation, where hydrogen gas is oxidized and oxygen gas is reduced to produce electricity, water, and heat. They consist of 2 electrodes, one positive cathode and one negative anode, which is sandwiched around an electrolyte. Hydrogen is fed to the anode and air containing oxygen is fed to the cathode. A catalyst, usually made of platinum, at the anode splits hydrogen molecules into protons and electrons, which will take different paths to the cathode. Electrons go through an external circuit, creating a flow of electricity, while protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. At the anode, the oxidation reaction that occurs is H2 yields 2H plus 2E minus. Hydrogen gas molecules are split up into protons and electrons. The protons will travel through the electrolyte, and the electrons will travel through the external circuit, generating electricity. Catalysts, which are usually platinum, are used to accelerate reactions by breaking apart the bond in the H2 molecule. At the cathode, the reduction reaction that occurs is O2 plus 4H plus 4E minus yields 2H2O, and this is where the oxygen gas reacts with the protons and electrons to form water. Overall, this reaction gives us 2H2 plus O2 yields 2H2O plus electricity plus heat. Redox reactions are key in fuel cells because they involve a transfer of electrons, which directly generates electricity. Hydrogen is ideal because it has a high energy content per unit of mass and produces only water when oxidized. Its abundance in nature, especially when split from water using renewable energy, makes it a promising long-term fuel. The simplicity and efficiency of hydrogen's redox reaction provides a blueprint for clean, scalable energy generation.
Hydrogen fuel cells are the technology of the future, and we need more investment and research into them to unlock their full potential. They are clean, powerful, and already being used in places all over Canada. Unlike gas engines, they don't produce any harmful emissions, just water vapor. They are far more efficient and run far quieter than a gasoline engine, with future models expected to hit up to 80% efficiency. Comparing this to nuclear or coal efficiency, which is only 30 to 40%, we can see that the future of hydrogen fuel cells is massive. The downside, most hydrogen is still made from fossil fuels, and stopping that is tricky. But with our natural resources and clean electricity, we're in a great spot to lead if the government supports our transition. Understanding hydrogen fuel cells is essential. They're directly tied to two of the biggest challenges humanity faces today: climate change and moving away from fossil fuels. As energy demand rises, we need clean solutions that are actually ready to use now. Hydrogen fuel cells don't just cut emissions, they eliminate them where they're used, which is huge for public health, especially in cities. Canada has what it takes to lead, with the resources and research to make it happen. But we need more education and support to push this forward. Replacing fossil fuels with hydrogen won't happen overnight, but it's possible. With the right incentives and a shared commitment, we can make clean hydrogen a real part of our energy future. Thanks for watching.